Yeah, let us continue. So in the first session, let me revise just for 2 minutes. So in the first session, we have discussed the aim of the experiment, which is your transformation for the Fourier transformation. Okay, so basically we transform an image using Fourier transformation. Fine. Then we have discussed the objective of this our lab. Okay, so this is our objective. You can see here the main objective of this experiment is to understand some of the fundamental properties of the Fourier transformation. Then we discuss some introduction part by like why we need a Fourier transformation, what is the benefit of Fourier transformation, okay, and what are the properties of Fourier transformation. Then we discuss in detail the theoretical part. Okay, like what is the mathematical formula for the Fourier transformation. Then we have discussed how we represent Fourier transformation in magnetic spectrum, how we can represent it in a phase spectrum, how we can represent in a power spectrum. Okay, then we have taken some familiar images and performed the Fourier transformation, and we analyze the results. Okay, we have analyzed the result and we have seen what will be our different spectrums. We can see how our magnetic spectrum looks like, how our we can see image spectrum, phase angle spectrum looks like, and how our power spectrum looks like. Okay, so we have completed still now. Okay, so in this session we will discuss the procedure part and we will perform the experiment and analyze some of the results. I think it is clear to all of you. So let us understand the procedure part. The procedure of Fourier transformation is very simple. Okay, so we can say the experiment is designed to understand and learn the Fourier transformation concept. Okay, so basically we have designed this experiment. Okay, the experiment is basically designed basically to understand and learn how the Fourier transformation concept can be implemented. Okay, now this experiment consists of two parts. Okay, the first part is your forward Fourier transformation, which is your, you can say, DFT point, and second one is your importance of phase. So as we have already discussed in the theoretical part, okay, as phase angle or the phase spectrum plays a very important role or very vital role. So that is the reason most of the time we will not change the phase angle. Okay, so while changing the phase angle, we may come across some difficulties. Okay, so that's the reason we will not change phase angle, or it is have a very vital role in my Fourier transformation. So we will learn what will be the importance of a phase. Now, what are the different steps? Now, steps of the experiment are we can define. Now, this is my step number one. Okay, so what is the step number one? Now, step number one says select an image from the logic using select image option. So, first step that you have to perform. So, you have to select an image from logic where number of images are given. So, out of all images, you have to select any one of the image from it. Okay, so that will be you are having an option there. Okay, you will having the option there. So out of all the images, you have to choose any one image. Okay, Then once you select any one image, now select the region of the image to load in the input image panel. Now what will happen? Now we will have an input image panel. Fine. And this will be my object. Fine. There will be an image. Fine. Now what you have to do, now out of all these boxes, I have to choose any one box. That means I have to select any one image out of all this available so that I can load this image into my input panel. Now this will be my what input panel. Okay, now this image is loaded to this input panel. Okay, this is my step number one. Okay, we can say this two are step number one, or we can say this is the sub step of step number one. It is first we have to capture the image or provide input image to the input panel. Okay, then only we can perform anything on it, whether we will perform the Fourier transformation or whether we perform the image processing or whether we perform the image processing. Okay, so whatever we need, first of all, we have to provide an input panel or input image to the input panel. Okay, or we can say image panel. Now, the step number two. What is step number two? Say we have to select one option form. Now, as we have already said, so the entire experiment is divided into two parts. One is your Fourier transformation. Second one is your study of importance of phase. So now you have to select what experiment you want to run. If you want to run the Fourier transformation, forward Fourier transformation, then select the forward Fourier transformation. And if you want to study the importance of phase, okay, if you want to study the importance of phase, then you have to select the importance of phase. Fine. Now, if you selected the forward Fourier transform, suppose now if I want to perform the forward Fourier transformation, okay. Now, suppose what we want to perform. Now, I want to perform a forward Fourier transformation. So, I will select forward Fourier transformation and simply hit run button. Okay. So, as soon as you click the run, now this image, input image, okay, or you can say the input image panel. Okay, so it will be converted into your Fourier or frequency domain images. So we will apply DFT here. So how it is happening internally? Okay, in this lab, which as this is a virtual lab. Okay, so internally they have having a MATLAB code. Okay, internally they are having a MATLAB code. So as soon as we are uh, double clicking or clicking on run button, an event is generated. Okay, an event is generated. So basically, this is an event-driven programming. We can say the platform that we are looking is based on event. So we are performing certain event there. Okay, so what is the event here? So the event is as we click on the run button, an event handler will activate it. Okay, and event handler will be activated. And what does the event handler will do? It will call a method. Okay, so it will call a method or a procedure that will convert an image, or you can say the input image, to the magnitude spectrum. Okay, so now internally we are having a MATLAB procedure. Okay, so simply how we are converting? It is converting because of there is a event handler which is calling a procedure, and the procedure is basically written in your MATLAB or you can say any other language, programming language, to convert this image to the magnetic spectrum. I hope it is clear to all of you. I think it will be clear to all of how we are actually converting. Okay. Now, suppose if you want to execute the second one. Now, this is about the first experiment. Okay, part one. Now, if someone want to implement. Okay, so let me clear these things. Okay. Now, suppose if you want to implement the second experiment, that is importance of phases. If I want to study the importance of phases, then what I have to do, I have to select any one of the option. Now we are having, there we are having a choice like choice 1, choice 2, choice 3, choice 4, choice 5, choice 6. Out of all these 6 choices, okay, I have to choose any one of the choice. Okay. Then again I will press the run button. So what will happen? As soon as I press the run button, what will happen? It will then call an event, okay, or a procedure which will be going to study different uh, importance of a phase spectrum. Now the output result will be displayed in the output panel. So what is my third step? The third step is whatever the output you will obtain, that will be displayed in my output panel. Okay. Now there is an interesting observation here. Now that will be performed. Uh, so what is the interesting observation? Now we have to try advanced option with different combination of parameters. Okay, with different combination of parameters and compare the result. Now we will choose. We will test this one. Okay, we will see this one. So we will choose the advanced option out of all this choice. We will choose the advanced option, and with different combinations of parameter, we compare the results. Right. So this is the procedure part. So what step that we have to follow to implement Fourier transformation? Okay. Now this is our virtual lab platform. You can see here. Now this is a platform. Now you can see two boxes, say two panel. We can say. Now this is my input image panel. Okay. This is my input image panel, and this is my output image. Okay. Okay. And this is our, we have to select an image. Now let I will show you how we are performing. Okay, now first step, what I said, what we have in the procedure, you have to click on the select image. Now first of all, we click on the select image. So as soon as you click on the select image, the music will be appeared here. You can see this is my music. Now from this, what we have to do? Now I have to select and any particular image out of all this. Okay, so what I will do? So I will select an image from any one of these images. Suppose I selected this one, so I will simply double click. So what what is happened here, what is happened here. Now you can see as soon as we place this one, okay, so the input image is copied to the input image panel. Okay, fine. So now I will click on run button. Okay, I will click on the run button to execute. Now we are performing the experiment one. Okay, that's why I'm selecting what I have selected. I have selected for forward Fourier transformation. I'm performing the first experiment. That means I'm performing forward Fourier transformation. So whenever I perform forward Fourier transformation, so what I will do, simply I will pause on. Now you can see the resultant one. What we have get here. Now this is my output image. Okay, this is my output image. And as we have discussed in the theoretical part, okay, as we have discussed in the theoretical part, that the Fourier transformation is basically represented by your magnitude spectrum and as well as your phase spectrum. Now you can at the bottom you can see there are two spectrum are there. Now this particular image will represent you know this is my original image. Okay, this is my original image. Now this is your amplitude or you can say magnitude spectrum or we can say the amplitude of an image. Okay, basically you say this is amplitude image of Fourier transformation and this is your phase image of Fourier transformation. Fine. How it is converted? So at the background, okay, or we can say in the background, there is a processor. So as soon as we click on run button, okay, so there is the processor is activated. So there is a code written in the background which will be converting the given image to the your respective amplitude spectrum and phase spectrum. Now let us analyze with taking different images. So what we have how. So we'll select different images and check whether the amplitude and the phase spectrum will be same or it will be different. Okay. So we will select the different images and we will analyze whether the amplitude spectrum and the phase spectrum that we are getting here, whether they are getting same or different. Okay, so it is clear to all of you. Okay, so I will take different. Now you can see here. Now again select image. So I will select first. I will drag down to the first image. Now the first image is selected. Now it is simply forward. Then I will click run button. Now you can see there is a slight changes in. Okay, if you compare, there is a slight changes in the what amplitude spectrum. Okay. Similarly, if I select the another image, so let us analyze. So let me take the next image, image. Now forward Fourier transformation. Then perform home button. Now you can see the changes here. Now there is a two that in the previous case there is only one line. Uh, as you can see, the amplitude spectrum, okay, which is your only the vertical line. But here we can see that along the origin, your two lines are passing here, which is one is passing horizontally and second one is passing vertically. Okay, they are exactly coincide at the this brighter place, which is nothing but your shifted origin. Okay, it is shifted to the center. Fine. So we are not finding much changes in it, just changes in phase angle. Okay, so and we will not uh, change this phase angle because this is play a very vital role while image transformation. So let me take the next image and let us find whether we will get any changes. So let me select. So this is a image of white colors are there. No, this is white color. The background is gray color. Let us see what will happen. Yeah, you can now see there will in this case there are more lines which is crossing the centers. In the previous case, we are having only two lines. One is a vertical line, second is your horizontal line. But in this case, you can see number of lines. You can see this is one line crossing, again this is one line, this is one line. Then there are some dots are appearing here. More dots are appearing here. Okay, so these are some changes that we are finding in the uh, what amplitude spectrums. So let's select the next image. Okay, so we've done. Now you can see this is very similar to the result that we obtained of the second image. Yes or no? There is only two lines. There is one passing through horizontal and one passing through vertical. Okay, so let me select the next image. So we have already seen this image. So let us see once more. Yeah, it will be also very much similar, but there is some more scattered lines are presented in here, and there is some changes in the phase spectrum also. Okay, let me select the next image. Now we have done this one. Now you can see again the two lines are crossing each other, and the dotted is centralized. Okay, now you can see we are performing all these operations for color images. Okay, so that is the reason we are getting same type of somehow similar type of amplitude spectrum, because the range of this you can say the range of intensity range of these images is basically ranges from 0 to 225. So that is the reason when it is scatters, so we basically get somehow the similar magnetic spectrum. Okay, so let me finish this one. So by taking others, if you take this one and if you done. Now this we will get some different. Okay, this is like completely different from what we are getting the previous one. Why it is so? Now in this case, you can see here. Now this part of regions, okay, this part of regions is nothing but your only black and white color. Now this part of region is black and white, and this is your generally you can say the grayscale intensity measure. A different intensity level of grayscale are measured. That is the reason we are having a drastic changes in our amplitude spectrum. Okay, but in the all previous cases, we are getting the same result apart from that ambassador card. Because again, the ambassador card, you can say the major portion of that card was white in color. So that is the reason they are getting some changes. But in this season, you can clearly say the amplitude spectrum is completely different from what you are getting for other amplitude spectrum. The reason is this image is completely black and white. Okay, so I hope it is understandable to all of you. So let me select another image. Let's see any changes. No, there is no changes. It is somehow similar to the all other images that we have discussed. Let's select. Okay, let me get this tiger picture. So whether this will be show any difference or not. If you done. There is slight difference compared to other now because in this region and in this region there is some lines you can see or you can see the veggie part you can see here. Okay. Not much difference compared to that black and white, but somehow there will be a difference. Okay, some difference we can analyze. Okay, so this is your first part of the experiment where we have performed the Fourier transformation for the different images. Okay, So now let us perform the second part, which is your importance of phase, how the phases are important. If you remember the procedure, so what the procedure say, first of all, we have to select the images. Now let me select an image. I will start from again the first images. Okay, so we have selected. Then we'll go to the advanced part. So now I have to choose the second part here. Now which is your importance of phase. Okay, now we will run that. Now select an image for a face, suppose whatever choices, suppose this image you select. Now you can see uh, this is my initial image, which is you can say in terms of face, and this is image that you got, it's called a process image. Now if I change, you select another image. So if you select this one, fine. You choose this one, fine. Run. It's asking me the choice. Now this choice is this choice. Done. Now you can see here what we have done actually here. Now this is showing the clear difference. So what we have done here now, this is my actual image or initial image. Okay. Now I have changed the face or interchanged the face. Now I have interchanged the face with that black and white image. Okay. Now this process image. Now this is my process image. How this process image we are getting? Now this is nothing but the amplitude image of this original image plus the phase image of your that black and white image. So that is the reason we are getting the image in such a way. That means if we will change the phase, okay, if we will change the phase, the image will be completely changed. So that is why we said the phase angle plays a vital role. Fine. So I hope it is understandable how we are getting this process image. Now this is my process image. How we are getting this one? We are getting this one with the help of what? Now we are interchanging the phases. Okay, now I'm what we are doing? I'm changing the phase. Now this is basically generated because of amplitude of this original image plus the phase angle of this black and white image. So let me show you another example. Now you can check. Now if you take the third example, suppose this white car. Okay, now I will take this importance of phase. Okay, now we will run this program. Now it's asking me the choice. Now if I take the first one, the first choice, let's see what it will do. Now you can see the images is something blurred. What we are getting? We are getting a blurred type image. Okay, or we can say that most of all the black and white type image. Why it is so? Again, because we are changing the phase angle of it. Okay, so let me select one more image. Analyze this one. Fine. So we just selected. Now we will run this one. Now this okay, choice 4. Choice 5. Suppose I will give choice 5. Let us see what happened. The output there is not processing. Returning choice 3. We are not having any other choice, so we are having only one choice. Okay. So change the phase with only one choice. We have. So you can see here. So again, this is something black and white image we are getting. Okay. Now we select again. And take this Now if I choose the next one to choice one, now you can see the images are something hazy type. Okay, now we're getting images of hazy type. We're not getting the original image. Okay, okay, so we will check other images. I will take for if you take the other images also. Check here the sunflower image. Now this is my initial image. Now this is my process image. Okay, you can see the analyze the differences. What happened if you change the phase again? What is the importance of phase? Okay, so you take this one, and if you done, give me a choice. Yeah. Now you can see the difference. Fine. So everyone can see the difference easily here. What changes are done here? Changing. Then what will be the opening? Okay. Let me select the another image. The image of Taj Mahal. Now if you run, now this image shows. Okay. Then you can see the hazy part. And let me select. So what is the different? I think they are not giving the option for choice 4 and 5. Okay, in the procedure they clearly written. Okay, but I think this is not complete model. In the procedure they are clearly written. You can select any of the option for 1 to 6. But when we are running this experiment, okay, you can see when I am running this experiment, selecting the image. Suppose I am selected this tiger one. Okay, I'm going for the importance of phase. Then you must have the other options also, but there is no option for 4, 5, 6. Okay, no image is available. Okay, you can see no image is available. So what option is available? So only option is available is option 1. So maybe they have not given input for these choices. If we are having input for these choices, now we can change the phase angle. Now we can analyze. You may have get different images. Fine. आपके वहां पर अलग इमेजेस भी आ सकते थे, लेकिन यहाँ पर आप एक ही पैटर्न का इमेज आ रहा है। जब आप रन करो देखो कैसा आ रहा है, एक ब्लैक एंड व्हाइट या हेजी टाइप का आ रहा है। Okay, because every time we are changing the phase angle of same image. That is the reason whatever image you are selecting, whether this one or this one or this one, any of this image you're selecting. Okay, so what is happening? Now I am changing the same phase angle. If you are changing with the same phase angle, so what will there? Your amplitude spectrum will be same. That means the content of these objects are same, but some of your phase angle is different. Phase angle is changed, so it will be somehow forming a black and white or hazy type images. Fine, is it clear? I think it is clear to all of you. Okay, so there is one observation they said to observe, or interesting observation. So what they said? So they said try the advanced option for different combinations of parameter and compare the result. Okay, now we will check the advanced option here. I will go for the advanced option. Suppose I want to select, first of all, let me select the image. So I selected the image from the image panel. Now now I will go for the advanced option here. Now you can see in the advanced option we are having what? Inverse Fourier transformation with width masking. Now as we know that to get an inverse Fourier transformation, so I need this theta and r value. So what we will do now, first of all, I simply run this one. Let us see. Now getting the original image. Now you can see if I'm making this parameters same constant. Okay, that means it is my original image. Then suppose we have performed the DFT. Then suppose I want to get back my original image, so I have to perform the inverse transformation. Now while doing the inverse transformation, so I need these values called theta values and r values. Along with that, we need delta theta values and delta r values. Now let me change these values now this time. So again, I will select an image. Fine. Now what I will do, I will change these values. Now I will take theta values to 120 and this r values to somewhere around 125. Okay. Now this, so now you can see the changes, what changes I am making. Okay, now you can see the changes. I will take it at 70 and I will increase the amount 80, 90, 100. Okay, now you can see that these grids are already changes. Now what we have done while reconstructing the images, now I have changes some phase angle and amplitude. Now if I run this one, okay, so, okay, now I'm not getting the same result. But let me increase, further increase, and this further decrease, and further increase. Now to run this one, now you can see the slight changes in these two images. So what are slight changes? Now this is becoming slightly hazier one. Yes or no? Now this has become slightly hazier. Why it is become slightly hazier? Because of changing this value. Now further I will change this one if I run it. Now it is clearing. Now let me decrease further and done. Now it is becoming hazier. Let me decrease further. Now increase this one. This is R theta and this one. Okay, now you can adjust this parameter according to you and analyze the different process image, how this process image is changing with this parameters. Okay, now you can change these values or you can further reduce these values. Let me see what we will get. Okay, there is no changes. Suppose I increase this one, there is slightly no changes. Fine. Now you can analyze. Okay, you can change. You can set the different values. Okay. Now somewhere around this we are getting the hazier images. Okay. Now as you can see we are getting a hazier image. Now as you changes this value, you can see here your theta and r, delta theta and delta r values are also changing. Okay. So we will done with this experiment. Okay. Now we end this experiment here. Now we can go through this virtual lab and practice this experiment which have two different parts. Okay, and you can try this advanced option to check how the image is changing. So with this, we will have to stop the class here and we will continue in the next experiment.